everyone. Welcome to the latest Spotlight On interview. Today, I'm joined by James Giordano, and we're going to be talking about ethics, biosecurity, and our genomic data. James, if you could please introduce yourself and tell everyone a little bit about what you do.
Sure. Thank you so very much. I'm Dr. James Giordano. I am a professor in the departments of Neurology and Biochemistry and senior scholar in residence of the Pellegrino Centre for Clinical Bioethics at Georgetown University Medical Centre. I also serve as a senior bioethicist of the Defense Medical Ethics Center for the Uniformed Services University of Health Sciences here in the greater DC area. And I'm the executive director of the Institute for Biodefence Research, a federally funded think tank in the greater Washington, DC area that really focuses on those ways that emerging trends in biotechnology and biotechniques, biomedicine, can be used in those ways that impact global security, public safety, and national interests.
Fabulous. And public interest tends to go in waves. We've had nanotechnology and cloning way back. Now there's excitement and concern about AI and robots. What are the kinds of questions that those outside of your field should have in their minds?
Well, I think if we begin to talk about AI and robots, one of the questions that keeps coming up over and over again is the relative autonomy of these systems. In other words, are humans in the loop? Are humans on the loop, or are humans out of the loop? And what do each one of those iterations mean in terms of the viability for human involvement and the way that that AI system or systems will ultimately treat human users either as stake or shareholders or as objects or subjects of some kind of moral regard, which then brings us into the issue of whether or not one can develop AI and AI-like systems that are inherently ethical, which then begs the question, what ethics do we engage and how do we employ those ethics? Is there some builder's bias? And then what does that mean? And then the other issue becomes, well, what about the ethics of the way we use AI, which then opens a much larger Pandora's jar. Much of what we're using artificial intelligence for, machine learning and decision technologies, is to process the massive amounts of data that are required to engage the current level of convergent biomedical sciences. I mean, my particular field is in the brain sciences, interfacing with AI and data sciences, particularly as the brain sciences interface with genomics. What we're seeing is copious data on a variety of levels, from literally the subcellular all the way to the social, from the individual to the international, from the idea of literally the biological to the biopsychosocial and behavioral, all being integrated to create, if you will, definitions and descriptions, depictions of the human being, human condition, human behavior, predictions of human behavior, assessments of human behavior, and in some ways to modify human behavior and perhaps even direct human narratives and thoughts. So the question then becomes, what will we do with these data? How will AI treat these data? What do these data about the essence of us in our genomes and our genetic and neurological information, as well as all the information of our daily narratives and events, be filtered into these data systems that ultimately go into AI? And then the other question is, who's got the keys to the kingdom? Who holds provenance and custodianship over these data, and what will they be used for? So these are some of the key issues, I think, that are important for a general audience to understand. Because on one side, we see that these systems are essentially being developed for what I'll call the low-hanging fruit. In other words, we're aiming at benevolent means and ends. We're trying to do some definitive good with these things, with these tools, with this knowledge. But let's face it, what's good for me may not be good for you. If I acquire certain goods, are there going to be enough goods to go around for you? And who defines what's good? Culture, history, politics, economics? And if in fact that's the case, what happens then when those goods are unevenly and asymmetrically distributed? And what does that mean for the haves versus the have-nots? So the key questions as they unfold are apace with the data, apace with the technology, but are certainly deeply rooted in the realities of our social sphere.
Absolutely. And to dive into the genomic data side of things, more and more organizations are starting to gather genomic data from public for-profit companies to national or international biobanks, as well as military. Starting with public companies, What are some of the most prominent ethical issues that people should be considering here?
Well, I think they're really threefold, and they're not mutually exclusive. Number one, who possesses these data? So where are these data going? What repository or depository? Where is the provenance of these data, and where's the custodianship of these data? That's just basically who's holding the information. Now, as soon as you begin to ask who's holding the information, the next question arises, well, what's going to be done with this information in terms of not only its intent, but various diffusions of intent, which gets back to the first question of who's holding the data. If I'm holding the data and my systems are relatively secure, but there's some shared custodianship of the data, and or there are differential stakeholders in these data, so now these data are being used for a variety of different things, what you're tending to get there is perhaps diffusion of intent and or use. So the idea is not only what we're going to use these data for, we want to use them for A, B, and C, but now we drift from A, B, and C into D, E, F, and X, Y, and Z based upon, again, the diffusion of the user groups, the holder groups, the actionable groups. In other words, literally, who's got the keys? And then the third question that derives from that is, what will we actually do with these data? What will you use these data for? The ubiquity of data in our current society, realistically in our proximate future within the next 5 to 10 years, is such that in reality, much of what makes us us, not only in the present, but the historical us, our past, our relatives' past, and the integration of data across all of the realms of our existence, literally, the physical, the chemical, the biological, the psychological, the social, the economic, the political, are all broadly available. And although we see that the nodes in which these data may be housed, stored, and used are relatively secure, the way these data systems must operate is they must stack. They must link nodes, connect via edges within a network. And it's those network properties that allow these ubiquitous, massive amounts of data to be integrated in a formulaic way, to be put into, if you will, real world articulation, to be of use effectively and efficiently. But this then gets back to the issue of, if something is stackable, it's at those stack points that things might then be hackable. So it's not just a question of what we do with the data that are existing, but how might modifications of those data, manipulations of those data, also then provide the nexus for what might be precision targeting, precision manipulation of individuals, of collectives, of groups, and then what does that mean in the near, intermediate, and long term?
Absolutely, some real concerns there. And when we're starting to talk about groups as well, we've got national biobanks, such as the UK Biobank and the US's All of Us. They're collecting genomes with the aim to advance precision medicine. But then there are wider efforts, such as the Nigerian 100K Genome Project, and they aim to increase the diversity of our data sets, as so many have had Western foundations. What are the kind of things we need to be considering at the forefront of these projects in regards to risk and ethical limitations? How can we counter it before it becomes a problem?
That's a wonderful question. I mean, part of the issue is, as you just illustrated, I mean, in the simple phrase of providing exemplary illustration of who has beta banks and what they're doing with it. The question is, it's not just an issue any longer of a key number of countries. You're seeing diversification of capability and control. And with diversification of capability and control, you also get diversification of viable intent, as well as perhaps those means, those methods, those guidelines and standards by which any data will be accumulated and or used. What complexifies the issue to some extent is that it's not just a question of national interest within a particular geopolitical framework, but intense commercial interest, and that those commercial interests very often may be protected by intellectual property laws, both regional as well as international, and that commercial interests can veil political and national interests with regard to how data are being uptaken, not only into commercial enterprises, but those commercial enterprises that are then useful for developing techniques and technologies that can be used for initiatives of national security, intelligence, and defense, either kinetically in a warfare type of way, but more so, and increasingly more so, non-kinetically, to manipulate information, to be able to manipulate economies, to be able to essentially manipulate laws so that the data that are used to provide substantiation for information can then be not only manipulated or altered, but in some cases actually used, leveraged in terms of withholding or provision. In other words, the information itself carries some weight, economic weight, political weight, and perhaps even weight with regard to balances of power. So what we're seeing is that the multicultural nature, the multinational nature of the involvement in these particular areas of genomic data, biodata, biopsychosocial data, coupled with the use of AI systems, machine learning systems, and big data systems, creates a diversified field of a variety of different interests and intents. And although what we'd like to think is that the guidelines are relatively uniform and that there is consensus and concurrence, the truth of the issue is that that's not always the case. And certainly we know that the capability that is conferred by genomic information coupled with big data and AI allows the development of not only precision medical interventions, but perhaps also what we like to think of as precision problematics, precision pathologies, and what goes along with that. Case in point, for example, most recently, as you know, AI-based systems were utilized to be able to generate algorithms as well as complete formulas for the generation and development of novel drugs, novel compounds that had therapeutically beneficial aims and therefore applications. The exact same time, concomitantly, it was recognized that those exact tools could also be employed to develop novel pathogens, novel drugs, novel toxins that could have dramatic and nefarious impact upon human health.
And the term precision pathology almost seems sci-fi. How futuristic versus how present day are these biosecurity risks?
They're very, very real. I mean, as the COVID crisis brought into stark relief, in many ways, although we're aware of the relative burdens, risks, threats, and in some cases harms, being aware does not necessarily mean being prepared, and being prepared does not necessarily mean for being responsive and ready. Now, let me be absolutely clear. There's nothing in any of the information that I've seen over the past 2+ years to suggest or directly indicate that SARS-CoV, the COVID virus, was a manufactured bioweapon. There's nothing to indicate that. But that's an irrelevant fact. Whether something occurs naturally or whether something occurs through some implication or direct, explicit human involvement, not even oriented towards developing a novel weapon, but perhaps simply examining what potentials, what possibilities are capable by employing the technology, given the new means and methods that are available. These things then pose some potential risk of, quote, escaping back into the wild, and therefore accelerating unanticipated effects. And not only unanticipated effects, but in some cases, unregulable manifestation effects. So one of the concerns that has been generated, for example, with the COVID crisis, was might it be possible that directed research, gain of function research, trying to explore, for example, what are the possibilities of indigenous viruses to be able to mutate and modify and therefore pose risk to humans, was conducted in a way that, although was certainly within the parameters of what is considered safe, didn't recognize unanticipated consequences, didn't recognize what is sometimes referred to as runaway effects, so that simple modifications, although it may be thought are at no point risky for humans, and they're not in their current state, if then allowed to then be released back into a wild state, have a higher chance of mutability, have a higher chance of zoonotic jump, and as a consequence pose risk, not only to humans directly, but to animal species, to fauna, flora, agricultural species, balances of economic capability that are based upon not only these biological agents, but also changes in our environment and our ecologies as a consequence of global warming and climate disruption. So what we're seeing is that there are convergent factors that I'm not going to say are creating a perfect storm, but certainly are capable of creating perfect storms in a variety of domains, which only increases the necessity of being, number one, aware, number two, of not only qualifying what these risks and threats could be, but quantifying them, and doing so in a way that then utilizes whole of nation approaches, both individually within nations and cooperatively, so as to engage what we refer to as biosecurity by design. In other words, recognize as we go that each step that is beneficial may also carry with it certain burdens and certain risks. That doesn't necessarily preclude or exclude taking those steps forward, but that necessitates being aware of what we call footfall effects. Where are we stepping forward? What is the terrain, so to speak, that we're stepping into? Is it stable? Is it unstable? What do we know? What do we not know? And what do we do about those things we don't know and we can't do? And are we ready to take that next step forward? And in so doing, what things do we need to do to make sure that certain risks, harms, and threats are preventable? And those that may not be preventable are either retractable or recuperable, or at very, very least, in some way are forgivable, given the relative balance of benefits and burdens with specific groups of share and stakeholders in mind.
Absolutely. And can you run through, whether with a national lens or an international lens, what is our current framework for where that role of responsibility lies, those international guidelines, those policies and procedures, and what are the challenges and the gaps?
Yeah, I think that it's important to start perhaps on a national level, because it's always best to assure that your house is in order before you begin to interact with your neighbors, so to speak. But then it's also a question of how big is your house? I mean, what are the level of alliances, cooperatives, and in some cases, competitions that we need to encounter? And the reality of it is that bioscience and biotechnology, whether it's in genomics, whether it's use of cooperative big biodata, the use of AI systems, and a variety of other approaches in the biomedical, as well as other forms of natural life and physical sciences, it's becoming ever more multinational. Again, primarily the province of developed nations, but it's also creating new relationships between developed and developing nations. And it's also creating certain capabilities, incapabilities, and widening asymmetries between those nations that are developed and developing, utilizing these approaches, and those that are undeveloped and may not have access, or may then be forced into various types of codependencies that realistically are power balances written anew based upon what the philosopher Michel Foucault referred to as biopower, biopolitics, the manipulation of biological variables to be able to exercise power and control over groups of individuals, collectives, political bodies, and nations. So the question then becomes, how broad is the appreciation, recognition, sensitivity, and sensibility of these issues as the science and technology progresses forward? And are there guidelines, stipulations in place that provide, at very, very least, a level of awareness, if not accountability? And in accountability, the ability to address and to also to affect in a nimble way those procedures, those directions and trajectories that might be problematic in the near, intermediate, or longer term. The short answer to that question is that I'm optimistic in that an awareness of the current state of the science has prompted a number of different discourses that I think need to be dialectically engaged. In other words, that appreciate different views, different values, voices, and in that way become more synthetic rather than trying to just be imperialist, right? Or trying to advance a single position, but rather try to synthesize positions of what represents viable goods, right ways of doing things, what things should be prescribed or proscribed, by that level of again, engagement, synthetic engagement, integrative engagement. I am optimistic. However, I'm cautious, because what tends to happen is simply, if you will, by the very nature of the developments themselves, is that science advances in those ways that contributes to technology, the development of tools. Tool use contributes to the development of scientific knowledge, capability, and expansion of its various applications. And very often what tends to happen is an awareness of ethical, legal, social, and environmental issues tends to occur after the fact. In other words, we build the thing first, we intend its use, and then either through that use in a variety of diverse elements and diffuse factors and environments and implications, or through alteration of use, either intentionally or unintentionally, we then have to encounter what may be, if you will, various burdens that are incurred. And those burdens can then become various risks, if not threats and harms. So very often what has to happen is we have to wait for the technology and the science to mature. Else we can fall victim into being far too speculative and therefore kind of Pollyannish in our ethical, legal, and social and environmental address. Or we can be performative. In other words, what we can do is we can spend a lot of time and money into engaging ethical, legal, and social discourses and address over things that are not yet real. The goal here is, like any ethical discourse, to begin from fact. What can the technology really do? What can it not do? What are the capabilities? What are its constraints? What are we doing about those constraints? Are these challenges or are these new opportunities to be able to create inroads to do more? What are the consequences of doing more or not doing more? For whom? Who are going to be the share and stakeholders, if you will? What's going to be the character of the research and how that research is then applied in a variety of real world use case scenarios in a range of things, from literally agriculture to biomedicine, to daily life, politics, warfare, balances of economic power. And then ultimately, we have to consider how flexible will we be to put into place necessary guidelines and perhaps governances, and will we in fact mind those governances? Simply because a signatory treaty or a convention may be in place does not necessarily guarantee adherence, as we know. So again, on the optimistic side, we see things like the Biological Toxins and Weapons Convention, the Chemical Weapons Convention, international conventions and signatory treaties examining the use of various forms of data, how those data may be integrated utilizing machine learning. And that represents progress, and I think positive progress. But I think it's also very, very important to understand that we need that diverse view. And we need to go from the national to the multinational in those ways that engages that dialectic in a multi-perspectival orientation. Because what we don't want to do is what we did with COVID. We don't want to turn our eyes away and or create frictions and tensions and create competitiveness, and in some cases, conflict, where there should be cooperation. We don't want to establish barriers because of our inherent competitiveness, whether it's financial, has to do with hegemony and leveraging power, and in so doing, sacrifice public health, safety, security. And then this speaks of issues in terms of, well, how broad do we need to be? And this is where certain nationalistic interests, I think, have to be in some way reconciled with an appreciation for multinational and global risks, harms, and benefits.
Absolutely. And if you had to pick a dream structure for ensuring everything was streamlined, do you see us heading more to a collaborative approach in regard, if we compare it to space, where we have NASA and the European Space Agency, or do you see the need for a more completely international regulatory body that is putting out the recommendations, more similar to perhaps the World Health Organization, for example?
Well, I think it's important to look at any one of those multi-engaged organizations and institutions and examine two things. What have they done correctly and what have they not done correctly? In other words, to engage a process of not only acknowledging the benefits and, if you will, what arises from those benefits. I mean, the real goods that are capitalized by those organizations and institutions' efforts, but also to examine the gaps, gap identification and analysis. Why are there gaps? Is this something that's inherent to the structure? Is it something that's inherent to the way that structure functions? Is it the fact that we need a new set of structures? That those structures were based upon, for example, historical precedent, but that they may not comport with the 21st century world stage and the rise of, if you will, the new global shift. And then from there, how do you compensate those gaps? How do you bridge those gaps? How do you close those gaps? And what's it going to take to do that? And very often, I think what we're going to see is that previous conceptions of global balance of power need to be re-examined and perhaps revised. The idea of a superpower, as we move into the 21st century, I think really represents something that's almost anachronistic. Multiple superpowers, as well as superpowers engaging lesser powers and proxies, is becoming the new world order. This is what the philosopher and historian Roland Benedicter has referred to as the new global shift. And in that global shift, I think one of the norms is going to be a trend towards cooperative competition, co-opetition, where groups working in clusters, in other words, those clusters that are defined for the enterprise of the engagement, recognize that there are key elements and domains in which cooperation is essential. But that cooperation can also foster particular areas of competition. And that competition could be cooperative. In other words, there is some a priori decision or consensus about what realms and domains of relative capability hegemony are going to then be actualized. And that creates interdependencies and integrations whereby the system of checks and balances is inherent to the actual structure of the effort itself. There are a number of ways one could go about doing this. And our research group, working with others internationally, has looked at a number of different approaches. Certain approaches towards reflective or balanced equilibrium, a Thagard-based approach, for example, looking at some of the philosophical work of John Rawls, for example, in terms of looking at minimax or maximum capabilities and providing for those who are least provided or capable, and in other cases, maximizing benefit, minimizing burden and risk. And we've also proposed a very realistic approach towards a risk assessment and mitigation paradigm that engages a number of domains: responsibility for realistic assessment and reappropriation, revisitation of those norms and guidances that we have in place, asking key questions, what we call the W questions of what is the science and technology? When is it being looked to be employed? Why is it being looked to be developed or employed? Who will get it? Where will they get it? And then ultimately, which mechanisms are in place to try to maintain at least some equity as well as equivalence in distribution, use, affordability. And then framing that in what we refer to as the 6 C's. In other words, looking at the actual capability and constraints of the science and technology and those of us who develop and use it. The science and tech may be very, very capable, but our civic institutions may not be ready. And what do we do about that? What are the consequences of use or non-use? What is the character? In other words, what is the actual purpose? And how might that character then be either clarified or in some cases diffused? Realistically, what are going to be the contexts of use? Military, medical, social, political. And then how are those contexts framed? And then in some cases also, is there going to be the need for continuity of research, continuity of clinical care, if and when things go wrong, continuity of ongoing scientific development and technological use to be able to counterbalance those things that may go wrong. In other words, continuity of preparation and readiness, and continuity in the social sphere, in the political sphere, in the economic sphere, to remain nimble and flexible so that civic institutions can be prepared, ready, and responsible. And then ultimately, there has to be some discourse towards consensus and consent. If indeed we're going to go forward in these ways, then clearly there has to be some consensus among the share and stakeholders that will be affected and involved, and some modicum of consent in terms of those that will be downrange, downstream, and the recipients of either the science and technology and or its ripple effects. So I'm encouraged that there has been discourse in these dimensions. But I think, it took me the better part of 3 minutes, 4 minutes to say that. To do it, that's going to be a work in progress. It needs to be. But I've argued, as many others have, that the proverbial juice is worth the squeeze. I think if we fail to do that, the consequences of failing to engage processes such as that would be far more dire than the effort, time, and toil required to engage those processes ongoing and in a way that is cooperative.
And you're talking about technology and innovation there. We had earlier this year, a biotech company announced the $100 genome, making genomic data cheaper and more accessible than before. So what opportunities and challenges do you see when we're talking about increased data?
Well, I think increased data, increased capability, the use, for example, of relatively facile and easy to acquire gene editing and synthetic biological techniques, coupled with the ubiquity of media and information sharing and access, provide not only opportunities in terms of things that can be realized beneficially, but also opportunities for things to potentially go wrong. Like anything else, the greater the diversification, the greater the diffusion of intent and user groups, the broader the range of uses, and many of those uses can incur inadvertent misuse, inapt use, uses that are in some cases in tension or in conflict, where again, my goods are not necessarily the same as yours. And by me exercising what I think is a pursuit of my good, in some way impugn what you hold to be near and dear to you. Differential distribution of goods, resources, and services. And so ultimately, I think what tends to happen is as soon as this moves into the consumer space, very often the nature of consumerism is based upon commodification, is based upon profit. And in those ways, there's an inherent competitive aspect to that. So the cooperative aspect, in many ways, is predicated upon engaging some competitive edge, because that's what the market dictates. So in moving these things into more of the commercial sphere, commercializing data, commercializing bioscience and technology, and doing that in a way that may even be direct to consumer, you're increasing the diversification and diffusability of use in practice. You're also creating opportunities for inherent competition, and in some cases, conflicting competition. You're creating, in some cases, opportunities for constrained cooperation and collaboration. And I think what tends to happen there is you're going to need to advance the discourse to such a point where there needs to be consensus in terms of what are guidelines. When things are then released into the consumer model, released to the public, then I think there is a reciprocal responsibility in terms of keeping that public safe, as well as providing that public with those tools, tools of knowledge, tools of capability, tools of instrumentation, that will afford them the relative security to be able to use those things that are offered to them in ways that they recognize will be of greatest benefit, but incur the least burdens and the least risks and harms.
Absolutely. And a word you've actually used several times today is the word dire. So do you think the benefits of precision medicine and the gathering of our genomic data is worth the risks we're discussing?
It's a good question. I mean, I think in terms of what the worth is those things that we target to be worthwhile. I think like anything else, what tends to happen is we identify the benefits, and the benefits become the impetus for us to develop these things, articulate them, and use them in practice. We are benevolent in our intent. I mean, realistically, even those things that are used for national security, intelligence, and defense, warfare, are developed with the purpose of some good, defending what a group, a collective, holds near and dear, their way of life, their ideology, their politics, or in some cases, destroying those things that they fear represent real risk and threat to those things they hold near and dear. Come on, no country goes off to war, no country engages, no collective engages bellicose action, thinking we're absolutely wrong, but we're going to do this anyway. We all believe we're right. So part of it is, what are those things that are good and right? Are we ready to face the possibility of consequences that could be burdensome, risky, threatening, overtly harmful? Do we have the mechanisms in place to be able to, if not prevent these things, mitigate them? Are we flexible enough? Are we nimble enough? Are we aware enough on a variety of different levels with a variety of different organizations and tools to be able to note when we're drifting from whatever is our proverbial center line of benevolent intent into those domains that have trajectories that could be somewhat more problematic at very, very least, and in some cases, nefarious, or perhaps capricious to the extent that it creates tremendous asymmetries, and those asymmetries then become problematic, become disruptive to human life, quality of life, biosecurity on a variety of levels, from the cellular all the way to the social. So I think what becomes important is, as we spend a tremendous amount of time and energy investing in those ways we can develop precision biology and precision biotechnology towards identifiable goods, is to invest a similar extent of energy and a similar dedication of at least effort to recognizing how those goods might in fact have trajectories that begin to weaken, have trajectories that can incur differential goods, and what those differential goods by definition and in practice may mean and incur, and begin to model more effectively real world scenarios in the short and intermediate term, whereby those key factors can be identified early enough to be addressed and mitigated so that we maintain the beneficial effects and reduce the burdens, and in that way, seek to constrain the risks and possible harms.
Do you think we're currently on track to have those mitigations in place based on our current stances?
Oh, it's a really good question. I mean, I think that there are certainly notable and laudable efforts underway. I'm not the only voice in the field. There are many. Those voices are loud. Those voices are multi-perspectival. And I think those voices need to come together in a cooperative and coordinated way to be able to paint realistic pictures of not only what can, quote, go right, but what kind of things can go wrong and how we need to be prepared, ready, and responsive for those things if and when they occur. So I'm encouraged that the nature of the discourse to date has been relatively apace with the capability of the science and technology. And there is a relative awareness of not only what appears to be the evident benefits, but also an awareness of burdens. In some cases, burdens that are incurred if we don't go forward with the science and technology. But I think an equally profound awareness, an insightful awareness of what types of burdens the science and technology could incur based upon various trajectories of real world use. So I am encouraged by that.
It's great to know there's some optimism in the face of some big risks that we really need to be building our security. So thank you so much, James. That was fascinating.
Thank you. It was a real pleasure. Thanks so very, very much.
Hello everyone. If you enjoyed this video, then make sure you check out some of our other videos in our series by subscribing below or going to our website, frontlinegenomics.com. I hope you enjoy.